Okay, this is the last video from PACE 1077, and this is a little set education. There's some unusual terminology and symbols that we're going to introduce, okay? Let me talk first about set notation. How do we write the symbols to represent a set? A set is a collection of anything. So here I made a collection of 3 colors. Notice there are braces around it, not parentheses. We use squiggly braces. And then it's equals a letter, and that's just a code to make it easier sometimes to refer to a particular set. Let's take this first symbol here. It looks like kind of like a pitchfork or the letter E. Actually, that helps me remember it because it means the element. So I could say yellow is an element of set A. And that is a true statement because yellow is in set A. I could say yellow is not an element of set B, because notice set B only has these 3 in them: green, blue, and black. No yellow. So yellow is not an element of set B. That is a true statement. All right. So we use the element symbol if we're just talking about one member of the set. By the way, the PACE also talks about something called the null set, or sometimes it's represented with empty braces, okay? And I know this is kind of weird, but this actually is technically an element of every set, but I can't explain that to you. That's just weird. All right, here we go. Let's talk about subsets. If we have 2 or more, so let me put together the 2 Christmas colors, red and green. All right, I could say that this set that I just made up, red and green, is a subset of set A, because set A has red, green, and yellow, okay? But it does include both of these, and so these are an element, or a subset rather, okay, subset of A. Now the PACE makes the point that if I list all 3 of these, red, yellow, and green, then I cannot say that it is a subset of A because the sets are equal. They're the same thing. A subset has to be a smaller set of a larger set, okay? So it could be any 2. I could say red and yellow. I could say yellow and green. I could say red and green as I did here, okay? And the order does not matter. Okay, so that's element. If I said yellow, and let's say black, yellow and black, okay? Is that a subset of set B? And the answer is no, it is not a subset of B. Now, black is a member of that set, but notice that yellow is not in set B. So I cannot say that yellow and black, this set right here, is a subset of B. So this is a true statement, even though I'm saying it's not a subset. All right, there's 2 more symbols we need to talk about. This next one looks like the letter U, and that actually helps us remember what it stands for. It means the union of 2 sets. So if I put A in union with B, what do I get? I'm going to get red, yellow, green. Now this one already has green, so I don't list it a second time if it shows up twice. And then blue and black. Right? So union means put the 2 sets together and list everything that's included in either or both of those sets. And then the last one would be the upside down U, and that means the intersection, or where do these 2 sets overlap? What do they have in common with each other? And in this case, with this example that I have up here, the thing they have in common is, do you see this? They both have a green. And so we would say the answer is the subset green. It's the only thing they have in common. All right? As you continue through the PACE, you're going to see some diagrams called Venn diagrams that help illustrate the different elements of sets and showing what happens if they overlap and the things in between where they overlap each other. That would be the intersection. Any elements that are in everything, both sets, would be the union. Okay? So this is very different from any other type of math that you've done, but I don't think it's really hard. I always tell my students this is more like logic. It's getting our brain used to thinking logically, following rules, understanding definitions, and applying definitions to things. And that is a really important part of getting our brain organized while we're in junior high, getting those brain cells working together correctly, and prepare us for some of the math that we're going to have in future math courses. So this is a very important lesson, but I don't think you'll find it too hard once we've gone through this lesson. Study the examples at the beginning of each page, and I think you should do well.